So part of what we have to go over is this last topic of electrolysis. Part of what we have to go over is a unit called a coulomb and how that relates to a constant and a calculation that is on your equation sheet. First, to go over what electrolysis is. Electrolysis is kind of the exact opposite of a voltaic cell. So the lab that you just turned in, you showed if you put chemicals together in a certain way, you can create a voltage, and a chemical reaction occurs because of that. Electrolysis is the opposite, where I have to zap something with electrical energy in order to make it work. Notice the word non-spontaneous in the definition. A voltaic cell is spontaneous. Put these things together, it creates a voltage. The reaction occurs. Electrolysis, we are going to force something to react. It's almost like it's endothermic, where we have to add a whole bunch of heat in order to make this reaction occur. Well, we're adding a different type of energy. We're adding electrical energy in order to make this reaction occur. I believe the original definition of electrolysis was dealing with the decomposition of water. However, we can use electrolysis to decompose an ionic compound. You zap NaCl with enough electricity for a long enough time, you can create solid neutral sodium and chlorine gas. Not that I would advise you to do that, and the amount of energy required to do that would probably be very, very large. We actually will typically do electrolysis with solutions. That's what we're going to do next class. We're going to have 3 different solutions, and you're going to like the setup. It's a little rectangular 9-volt battery. We'll have a couple of wires on it, and then we have a couple of electrodes at the end, and we just stick it into the solution, and you'll see stuff happen. You'll smell stuff happen. Along with that, pretty colors will be observed. And chemistry is nothing if not pretty colors. If you ever watch Saturday football games, and then each university has their commercial about go to this university for this, when they show science, they show flasks and pretty colored solutions, because that's really what chemistry is all about. Why do we use electrolysis? Well, if we have a mixture, like an ionic compound even isn't technically a mixture, but we can get a pure element from it. Electroplating will use electrolysis. For example, nickel is a cheap metal that's often used in jewelry. But nickel doesn't look pretty. So what they will do is they will gold plate nickel. So then it looks nice, but then the inside of it isn't gold, so then it's less expensive. Graham, you know why I know all this about jewelry that's nickel? My wife has a nickel allergy. After a while, that gold plating will wear off. And then her earrings will give her, puffiness because she's getting an allergic reaction in her ears. So I will never be able to buy her cheap-ish jewelry, because after a couple of years she will know that I spent less on the non-pure thing. This is very unfortunate for me. I really should have picked a mate that did not have a nickel allergy so I could be cheap without her knowing. Because that's the beauty of plating things. You don't know unless you cut it open, and why would you cut open the inside of a ring? So again, there's the plating, and again, protection against protection of substances. Galvanized nails would be an example of that. And then the last thing I have down on this slide is we can do some math with this. So the quantitative analysis is what we're going to be talking about with notes today. Again, I think our textbook does a very nice job of giving you pictures and showing you what electrolysis is. So my focus is going to be less on that part of electrolysis, although I wanted to give you at least one intro slide of electrolysis before I dive into the math. So the textbook will talk more about electrolysis. I'm going to talk more about the calculation. What you're going to see is I can give you an ionic compound or a solution, and I can ask you how much solid is created if I supply this much energy for this amount of time. So if we know how much we're putting in for a certain amount of time, we can then calculate how much is given off. I would say when it comes to electrochemistry, again, I understand you're going to have a big test on Thursday and you're going to want to move fairly quick through some of the problems if you can. There are two types of electrochem situations. Voltaic cell, which is the ones that naturally occur, think about the two beakers in the U-tube, and electrolysis, where I give you one thing and we're trying to zap it with power to break it apart into two different things. Very important when you read the question to just try to identify to yourself, which scenario am I going over? And I think that's one of the things I put on the reading guide as well early on, and our textbook also goes over of what's the difference between these two different types of electrochemistry problems. Because if you don't know how to identify what problem you're trying to solve, you are most certainly going to solve it the wrong way. I mean, you probably saw that with Unit 1, where if you don't know exactly how you're supposed to calculate it, you fall into those issues as well. So what we're going to talk about then is a unit of electrical charge referred to as a coulomb. Now, the root word coulomb, maybe you've heard the term coulombic attraction before, which coulombic attraction is just referring to positive and negative charges attracting one another. A coulomb is equivalent to 1 amp second, which means absolutely nothing to you probably. But mathematically, if I wanted to solve for how many coulombs I have, I just have to multiply my amps times my seconds. See if I can write directly on here. This is the equation that I just hand wrote on here that your AP sheet will give you. I equals Q times T. Hopefully we recognize lowercase t's for time. So that one's kind of self-explanatory. Q is the charge, which is the coulombs. And then I is the current, which would be the amps. And so that's the equation that will be given to you on the equation sheet. Typically, you want to solve for your number of coulombs because we can relate coulombs to electrons, and I'll show you that on the next slide. So the last thing I have written down here, which, let's go back for a second. I'm going to have to erase what I just wrote here. So I'll give you a second to jot this down. The last thing I have down on this slide, I don't recall off the top of my head, but I'm pretty sure our current textbook shows you the path you take in order to solve the type of problem I'm about to show you. I'm just putting that path down on the notes. So you can either jot that down or not. That's kind of up to you. Again, let me get rid of this so then I can show you this last part. If we are given the current, so the amount of amps that we're putting into our electrolysis process, and we're given the amount of time that we're doing it for, multiplying the two will give you the number of coulombs. So that would be one step right there. So this times this, giving me that. On the next slide, I'm going to show you there is a way that we can convert from coulombs to moles of electrons. Electricity is all about the flow of electrons. The amount, how fast it's going, that current part of it. So there's a conversion that I'll give you in order to solve for moles of electrons. Once you have moles of electrons, you can convert using stoichiometry in like an oxidation equation from electrons into something else. Remember in the lab that you just turned in, you probably had an equation like, let's think here, what was oxidized in that lab? The zinc was, right? Zinc yields zinc plus 2 electrons. Well, for every 2 electrons, there's 1 zinc. So we can do stoichiometry within just an oxidation or just a reduction equation in order to go from electrons to moles of whatever we want to talk about. And then it's pretty easy to convert from grams. If you have the moles of a substance, you just use your periodic table. So again, that path is what we're going to be practicing with our math in a little bit here. I believe the textbook shows it to you, but I know our old textbook did, and I always wanted to point that out to students then. We need, in order to do that math, something called Faraday's constant. And Faraday's constant is referring to the amount of coulombs that are carried by a mole of electrons. That value is 96,485. That number is given to you on the equation sheet. So again, typically on the AP equation sheet, on the left-hand column are all the equations. On the right-hand column are constants, and they even give you what letters stand for which things. So the 96,485 coulombs per mole is what we can use to convert from a number of electrons, or I'm sorry, from coulombs to a number of electrons. My last slide is going to be one practice problem that I'd like to show you and go over. Then from there, you picked up a sheet on the way in that has some practice problems. I would suggest maybe doing one or two, and then you'd move on to the reading guide, which the reading guide will go over a couple of things, both what is electrolysis, a little bit of math, and then it'll also talk about what if I have a mixture of things when I do electrolysis. So, I would recommend not writing down this entire problem, instead of just kind of following the path of the math that I choose. But this is a somewhat typical problem. Molten. Typically, molten's used for either metals or ionic compounds that are usually solid, but we heated it up enough to be liquid version. So a liquid calcium chloride in an electrolytic cell. Okay, notice the vocabulary that's being used. It's not called a voltaic cell. Voltaic cell is what you just turned in a lab on. Electrolytic, referring to electrolysis. Suppose I give a certain amount of amps, 0.452 amps, for 1.5 hours. I could ask you how much would be formed at the anode. Heck, I could ask you how much is formed at the cathode as well, but this one's asking for the anode. So this is a fairly typical question dealing with electrolysis. Again, don't worry about writing down all of it, but here's how I would suggest going about it, and then I will show you this on the Smart Notebook. You need to know the half reactions. You need to know the oxidation equation, the reduction equation, because we need to know how to relate the number of electrons gained or lost to whatever product we are looking for. So that's why I say you should be looking at that. And then from there, here's those steps that I showed you on the previous slide. Again, notice in the question, as you're becoming a stronger AP student with particular assessments, annotate questions. So highlight, circle, whatever might be what you are given. Well, I was given an amps and I was given an amount of time. Again, if you look on your equation sheet, there's one equation on the very bottom that goes over this specific thing. Current times time equals coulombs. Well, coulombs is nice, but then how can I get to moles of electrons? Previous slide, Faraday's constant goes from coulombs to moles of electrons. If I have a number of electrons, I can then use my half reaction to convert it to whatever I want to look at. Peter?
Faraday's constant on the equation sheet?
Yes, it is. So just like on the bottom left-hand corner is that equation, on the bottom right-hand corner is that constant. Okay. The only constant that I would suggest students know is the heat capacity of water, 4.184 joules per gram degree seconds. Pretty much any other constant is either given to you in the problem or is given to you on the equation sheet. Like the R values for the ideal gas law, that's given to you. So there's certain things. Heck, STP is given to you of 0 degrees Celsius in 1 atmosphere. So they typically avoid you memorizing much in the way of constants, more just knowing what math to use and when. All right, so I'm going to switch over out of the PowerPoint slide to show you how to solve this question. I think it's important to know what we started off with, which was calcium chloride. Within calcium chloride, it's composed of calcium plus 2 and Cl minus. Are we good with that statement there? I'm trying to figure out what am I starting with. When you do the reading guide later in the hour, again, one of the things the reading guide is going to take this a step further in is we could try to do electrolysis with a mixture of things. And you have to be able to predict what part of the mixture is going to be created at the cathode, which part is going to be created at the anode. And when I looked at my answer key yesterday to the reading guide, I even hand wrote on there, first figure out what do you have to start with. That makes a difference. Calcium can only gain electrons. There is no calcium plus 3 or plus 4. So I know that this is going to gain electrons to form solid calcium. And if this were to occur, is this oxidation or is this reduction? Reduction. Remember, you gain electrons, you reduce. That means chloride is going to have to lose electrons, except for when chlorine loses electrons, it doesn't become monoatomic chlorine, it becomes diatomic chlorine. Remember, it's one of our diatomic elements. In order then to balance that equation, I need to put a 2 in front of my chloride, but now my charges aren't balanced, so I have to put a 2 in front of my electrons. This is the oxidation equation. The original question asked how much product will be formed at the anode. What process occurs at the anode? Oxidation or reduction? Oxidation. Remember, they both start with a vowel. And if I'm asking what thing will be produced, this question is asking for the amount of chlorine. So before I do any real math, I first wanted to figure out what would be made at both electrode, and now which electrode should I focus on? I'm going to focus on that one there. Now the question gave me 1.50 hours. In order for our equation to work, our time has to be in seconds. So 60 minutes in 1 hour, 60 seconds in 1 minute. That'd give me a total amount of time of 5,400 seconds. Now that I have my amount of time, and I have my amps that were given to me, 0.452 amps multiplied by my 5,400, that will give me, I'm going to kind of ignore the 3 sig digs for now. I'll carry that at the end though. Heck, 2,410. I'll keep the sig digs. So, step 1, I try to figure out what in the world am I going to be solving for, so as I go forward, I have an idea of what do I want to get to. I want to get to the chlorine. Step 2, that new equation that you were given. So again, that equation on your equation sheet is I equals Q divided by T. I wanted to solve for Q, which is the coulombs. So I take my I, my amps, times my time. You don't have to memorize what I stands for. It says it on the equation sheet. I is current in amps. Q is charge in coulombs. T is time in seconds. So I threw a new equation at you with variables, but you don't really have to memorize that because it is given to you. Now, maybe for today while you're working on stuff, hopefully you wrote down that equation so it helps you out. But now I'm at coulombs, which is a unit that probably a lot of us are like, what in the world is a coulomb anyways? Really, the coulomb is the way from us to get from electrical stuff to how much actual physical stuff can we make. So it is kind of talked about the current overall. This is my 2,410 coulombs. I want to go from coulombs to moles of electrons. And there's 1 mole of electron for every 96,485 coulombs. That is Faraday's constant, which is given to you. You just have to know how to use it. Now, if you wanted to, you could just stop here and solve for moles of electrons, but I'm feeling kind of stoichiometry-ish. So I'm just going to keep on going more conversions after this, right? So right now I've just canceled out coulombs, top and bottom. I'm left with moles of electrons. I want to go from moles of electrons to what I'm trying to solve for, which is the chlorine. I have a ratio of stoichiometric coefficients between these two. There are 2 electrons for every 1 Cl2. That's my next conversion. I want to get to Cl2, so there's 1 Cl2 in my balanced equation for every 2 electrons. Because if I do that, electrons cancels out top and bottom. I now have moles of chlorine. Question didn't ask for moles, it asked for, well, I guess it said how much product would be formed, so we could stop at moles. Probably should have wrote the question better and said how many grams, because we could convert this to grams as well, which Cl2 is a diatomic, so that's 70.90 grams per 1 mole. And if I do all that, 0.886 grams of Cl2 is what I ended up with for an answer. You could actually see a calculation that goes in the exact opposite direction, where it gives you the amount that you need to create. So how much time do you need to put in with a certain amount of amps? Or you have an hour and a half to make 5 grams of calcium. How many amps do you need to do? So you could do the exact opposite version. But this is the last calculation that you have to be aware of when it comes time for the test. I would say electrolysis is not as nearly as much of a point of emphasis as voltaic cells are. Every year I see voltaic cells on the free response. I occasionally see electrolysis on the free response. I'm assuming it's more likely on the multiple choice. But at the same time, I want to make sure that you are aware of this last calculation. Stop this.